So this lesson is going to be about congruence and similarity and how those two things are related to each other and some of the differences that are going to arise. This is going to be a little bit tedious because it is a lot of definitions that we have to front load before we are prepared to deal with some of the application problems that we're going to do. First thing we have to know is the difference between congruence and similarity. So congruent shapes, they're going to have all the same side lengths and all of the same angle measurements. However, with similar shapes, they're going to be the same shape, but they may not be the same size. And we're going to look at, in this video, the relationship that arises with similar shapes. If you think back to Unit 1 and what we talked about with Unit 1 with our transformations, these are the types of transformations that created isometries. This was the dilations that we did. So dilations created similar shapes because they changed size, but everything about our congruent shapes is where isometry comes into play. So with this one, we have to be very careful about how we think of this. They can be similar and not be congruent, but there's no way to be congruent without also being similar. And I want you to think about why and see if you can come up with an explanation and bring it to class tomorrow, and we're going to talk about why this is true. So here is this special relationship that I was just saying a few minutes ago. When we have a similar figure, we're going to have sides that correspond to each other and angles that correspond to each other. That means a side, let's say AB on my pre-image, would correspond with A prime, B prime on my image. So that's what I mean by corresponding. It's the side or the angle that relates the pre-image to the image. Corresponding sides have to have the same ratio between the two figures. So the ratio that I see between AB and A prime, B prime has to be the same ratio that arises from BC to B prime, C prime. And the ratio that we're going to look at as a fraction, and we're going to compare sides with fraction as a ratio instead of using a colon. So here's a picture that we've got. So we've got two similar triangles. We're going to have corresponding angles that have the same measurement, and like I just talked about on the last slide, the corresponding sides have to have the same ratio. So I would have to check in this case that the ratio of 4 to 12 would be the ratio of 2 to side B, which is 6. And the other thing I would have to check is that these angles in here are the same as these three angles in here. Side lengths do not have to be the same for similar shapes and similar triangles. Angle measurements absolutely have to be the same for similar shapes and similar triangles. And we'll talk a little bit more about this example tomorrow in class. So now I'm going to give you a few ways that I can actually prove that that triangles are similar. And now I'm going to speak specifically about triangles. So one thing that I'm allowed to say, similar triangles, they have to have angles that are the same measurement. It absolutely 100% has to be true. And my sides are going to be proportional. This is what I mean by the ratio. I'm going to put this into two things that I'm allowed to use, two statements. So this is my first statement. I could have an angle-angle similarity. So let's say that they only gave me information on a triangle about angles. If they gave me enough information to say that at least 2 of the angles on those two triangles are congruent to 2 angles on the other triangle, then I can say that these angles are similar. because I have a 90-degree angle here and a 25-degree angle at the vertex here, and I have a 25-degree angle and a 90-degree angle here, I can say because I have two angles that are corresponding and congruent that these two triangles here would be similar. And the last statement that I'm allowed to use is if I have information about the sides. If I have proportional sides from one triangle to another triangle that relate to each other or correspond to each other, and they create that same ratio or that same proportionality, then I can say that those triangles are similar. And your mission tonight, based on these two pictures here, these two triangles, I want you to try to see if you can set up a ratio that would relate, we're going to call this triangle A, to triangle B. So when you're going through this right now, I want you to set up ratios that relate triangle A to triangle B, and see if you can figure out what sides have to correspond to each other in order to create ratios that would prove that A and B are similar triangles. So that's your mission tonight. If you have any questions about anything that I went through on this video, please make sure that you make a note in your notebook or on the side of the page and ask me at the beginning of class tomorrow.